All right, so this video is going to go through an example of determining a rate law, determining rate constants, and finding rates of reactions in specific circumstances. Now remember, we have to use experimental data to find orders of reactions and to determine rate laws. It's not something we can get from a balanced chemical equation. Nonetheless, we have our basic equation right here, A plus B yields C, and we have a data table showing the variation of concentration A and concentration B and how it affects the initial rate of the reaction. Our goal is to use this experimental data to determine the rate law, to determine the rate constant, and determine the rate of the reaction when the concentration of A is 0.05 molar and the concentration of B is 0.1 molar. So let's get started. My rate law. I know my rate law is going to be a variation between concentration of A raised to some power and concentration of B raised to some power. And the only way to figure out those orders or those exponents of the reaction is to look at my data. So when I look at my data, I'm looking specifically for data points where only one concentration is changing. So when I look at experiment 1 and experiment 2, concentration of A remains constant. So I'm going to look at my concentration of B and see what happens. It goes from 0.1 to 0.2, which means it's being doubled. And as a result, my rate goes from 4 times 10 to the negative fifth to 4 times 10 to the negative fifth. So hold on, let me get that right. When the concentration of B is doubled, the rate does not change, so it's essentially being multiplied by a factor of 1. So what the heck does this exponent have to be on this factor to get a change of 1 for our rate? So what does 2 have to be raised to in order to get this factor of 1? If I raise 2 to the 0 power, that would get me my factor of 1. So that must mean that the reaction is a 0 order reaction in terms of B. So I can write this with a little bit more information. Concentration of A raised to an x power, but concentration of B, that's raised to 0 power. Now, the 0 power is going to make that value 1, no matter what the concentration of B is. So I could even go a step further and omit it from the equation and just write a to the x power, since B is going to have no effect on the rate. So now let's look at experiment 2 and experiment 3 and see if we can use that. For going from experiment 2 to experiment 3, I am going from 0.1 to 0.2 for my concentration of A. However, I am also changing my concentration of B from 0.2 to 0.1. So these are two different changes that are happening right now. I can't be sure that my rate is changing as a result of my change in concentration of A or as a result of changing the concentration of B. So I can't look at experiment 2 and experiment 3. Instead, I'm going to look at experiment 1 and experiment 3. A is still changing, however, B is going from 0.1 to 0.1, so it's remaining constant. So I'm doubling my concentration of A, and what's happening to my rate? It's going from 4 times 10 to the negative fifth to 16 times 10 to the negative fifth. So over here, I'm going to write out my thoughts. A is being doubled, and what's happening to R? R is being quadrupled. It's being multiplied by 4. So this is not the same factor. So what must I be raising 2 to get 4? Well, if I square it, that will get me this factor of 4. So I must be squaring my concentration of A and my rate law. It's a second order reaction in regards to A. So I've been talking about order as I've been doing this, hopefully to help you also recognize that that might be a question you get asked too. What is the order of this reaction? What is the order in terms of A? What is the order in terms of B? So I'm going to add that over here. Right now, since I have a complete rate law, my overall order is going to be the sum of the order due to A and the order due to B. So 2 plus 0 will get me an overall order of 2. My order for A is second order. So you can say it's second order for A, the concentration of A. And since there's an exponent of 0, it's 0 order for the concentration of B. once again, all questions that you may or may not be asked in the future. So that's sufficiently answered letter A. Letter B is asking about finding the rate constant. So now that I have my rate law, I'm going to try to figure out what is the value of this K constant. And I can do this by picking values from my data table and substituting them into my rate law. So I'm going to work with experiment 1 for simplicity's sake. My concentration of A is 0.1, so that's what I'll substitute in for A. And then my rate is 4 times 10 to the negative 5th, so that's what I'll substitute in for R. So 4 times 10 to the negative 5th equals K times 0.100 squared. So when I solve for K, 0.1 squared is 0.01. So I'm going to have 4 times 10 to the negative 5th equals 0.01 K. I'll divide both sides by 0.01. And what do I get? Divided by 0.01. I end up getting 4 times 10 to the negative 3rd for my K constant. But this doesn't give me my units. This is just numerical values. So I got to think a little bit more about what my units are going to be. So I know that for a rate, my units are molarity over seconds. And K, I don't know the units in this case. But I know that my concentration is molarity, and it's being squared. So if I wanted to solve for the units of K, I could multiply both sides by 1 over molarity squared to isolate it. When I do this, this isolates K, and I can simplify the left side to be 1 over molarity seconds, or inverse molarity, inverse seconds for my units. So now that I have the magnitude of K and I have my units, I can combine this into one neatly packaged answer. My rate constant is 4 times 10 to the negative 3rd, inverse molarity, inverse seconds. So this is my answer to B. So now, C asks, what's the rate of the reaction when A is a concentration of 0.050 molar and B has a concentration of 1.00 molar. So now that I have a rate law and I have my rate constant, I can solve for my rate by substituting in all of my known values. So 10 to the negative 3rd, inverse molarity, inverse seconds, times my concentration of A, 0.050 squared. Hopefully my pencil doesn't die during this video, but times 0.050 squared. I guess I should put units on there to be consistent. This is molarity squared. When I multiply all of this, the numerical value I'm going to get 4 times 10 to the negative 3rd times 0.050 squared is going to get me 1 times 10 to the negative 5th. And my units, if I wanted to just double check that I did things right, I'm going to end up having one of these inverse molars, this inverse molar, canceling out with one of these molars because this is molar squared, which is going to leave me with 1 molar left, inverse seconds. Now, how could I rewrite this? I could rewrite this as 1 times 10 to the negative 5th molarity per second, which is exactly the unit